this last section, we're really not learning any new types of problems. It's just some applications of problems, or some situations where we would use some of the things that we've been seeing. So no new equations to solve, just using some of this stuff. One application that we use logs in a lot is in dealing with pH. So if you guys notice on the top of your notes handout, I did kind of give you some of the important formulas that we'll be using. I'm not expecting you to memorize this. If I gave you a pH question on the test, I would give you the formula in there. So you just have to be able to use the formula. That's all we're doing today. So pH is actually calculated by doing a log. It's the opposite of the log of H3O+. Okay, that's the hydronium ion concentration of a solution. So for example, everybody will need a calculator. So pull out your Chromebooks. All right, so the first part A, find the pH of a solution with H3O+ equal to 2.5 times 10 to the negative 4. So all we are doing is typing this into the equation. Negative log 2.5 times 10 to the negative 4. I would like for everybody to type that in so we can make sure we don't have any issues with that. Typically, pH is rounded to just one decimal place. So what'd you guys get? 3.6? Part B. So I switched the question this time. I want the hydronium ion concentration if I know the pH is 7.1. So I am going to plug the 7.1 in for the pH in the formula, and that's the negative log of the hydronium ion concentration there. So now we just have to figure out how to solve this. What could we do with the negative in front? Do you just want to divide by -1? That'd probably be the easiest option. We could take it into the exponent, but we could just easily divide it over to the other side. This H3O+, that's just like solving for x. So these are equations like you were solving last night. If you have a log on one side, we always change it to the exponential. What's the base of this log? So it's 10 to the negative 7.1 equals the thing I'm trying to find, my H3O+. So if you type in 10 to the negative 7.1, okay, you are going to get a weird looking answer here. Just like the one I gave you, it's giving you scientific notation. So it's 7.94, a bunch of decimals, and if you look at the end it says E negative 8. So this is like 7.9 times 10 to the negative 8 power. So make sure you're putting this in your calculator so you can understand what your answer will look like. So the equations with these aren't going to be too nasty to find. It's just a matter of plugging things in and using our calculator. Any questions on that one? Okay. Let's look at our next thing I want to talk about. Exponential growth and decay. So this is referring to how things change over time, how the amount of something changes over time. And the formula for this is y equals y sub 0 e to the kt. So I did not, the box at the top of your handout, first box on the right, you need to write your formula in there. Y just represents the amount at any given point in time. Y sub 0 is the starting amount. K is a constant, T is the time that has passed. If your K is greater than 0, that will turn into growth, so as time goes on we have more of it. If our K is less than 0, that's decay. As time goes on, there's less of it. So let's look at a sample problem with this. If 800 grams of a radioactive substance are present initially, and 2.5 years later, only 400 grams remain, how much of the substance will be present after 4 years? So, this is talking about this exponential growth and decay. Y sub 0 is how much we started with. How much did we begin with here? 800. What's the 2.5? That's a time. And when my time is 2.5, how much do we have? 400. So in this, I want to stress something. The Y sub 0 and the K, those are like set values. Your starting amount doesn't change. That constant doesn't change. Now, my T and my Y do change. You know, after 2.5 years, we have this much. After 3 years, we would have this much. So what I'm doing first is giving you the information to find that K, find that constant value. So we're going to plug everything in and find our K. So our Y was 400 equals 800 e to the K times 2.5 power. So these are like equations that we were solving. What would I do? Divide by 800. So that's 0.5 equals e to the 2.5 K power. Then what would you do? We can't get a common base, so we add the natural log. Since it's an e, we use that ln. Okay, so we have the natural log of 0.5. We know the natural log of e cancels. So divide by 2.5. And K is negative 0.2773. What this is giving me is my actual equation. Now I know my K value. So we can find the amount we have at any given point in time by using this equation. Alright, so then the question was, how much will be present after 4 years? So what would you do? Plug a 4 in for T. So if I put that in, $263.858, and that would be grants. Does that answer seem reasonable? We started with 800. After 2.5 years, we were down to 400. So after 4 years, this amount is decreasing every time. We're down to 263. So we had to use the information to find our constant, and then we could find the amount at any given point in time. Any questions there? Let's do another one along these lines. Why don't you guys see if you can set up this first one? So it's really kind of identical to the last one, just different numbers. So see how far you can get setting that up. Almost identical. What's our y sub 0? So we know that will always be the case. We have to find this k value. So we're going to take the 3 years later, we have 300 grams. So 300 equals 600 e to the k times 3 power. Divide the 600. I don't know if you guys, have you ever heard the term half-life in your science classes? This is finding the half-life of something, how long it takes until you have half of what you started with. But, okay, then we add our natural log. We know the natural log usually drops. So then to find your k, you have to do the natural log of 0.5 divided by 3. And that gives us a negative 0.2310. So this is our equation. So then no matter what time I give you, you can easily calculate the amount we have. So I want to know the amount after 6 years, so you plug in a 6 for your t. And we get 150.044 grams. Next type of application I want to look at is one that we've used before. We've done interest a lot. I put the interest formulas on the top of your paper in case you've forgotten them. You know I've always given them to you. You don't have to memorize those. So I want to know how long it would take for the money in an account that is compounded continuously at 5.75% to double. When it's continuous interest, which formula do you use? Okay, the 5.75%, what is that? The rate. Remember, you always move the decimal back 2 places, so the r is 0.0575. That's really all I gave you, except that I want it to double. So I did not tell you your p and your a, but we could make up some nice easy ones. Give me a value for p. 100. So if I want it to double, what would my a be? 200. Alright, so if we plug in 200 equals 100 e to the 0.0575 t. Divide our 100 over. Then we need to natural log. On the right, we know the natural log and the e drop. we just divide by the 0.0575. So we get 12.0547, so it's about 12 years. So we've solved problems like this before, except I never made you solve for the time in the past because we didn't have the logs, but now we do, so we can solve these. Let's do one more interest problem. So how long would it take $1,000 invested at 2% interest, compounded quarterly, to grow to 2,700? Which formula is this? Okay, so all of those are there on that front. What is the 1,000? P, that's the amount today. 2%, so my R is 0.02. Compounded quarterly, what's that telling me? N is 4. To grow to 2,700, that is the so plug in. And what are we going to do? We can't distribute the 1,000 in here because of the exponent, but we could divide it over. So 2,700 divided by 1,000, give me a 2.7. You could simplify inside the parentheses. 1 plus 0.02 divided by 4. That's not going to be too bad. That's 1.005 to the 4t power. Now this is like a problem I would have put on yesterday's homework. What would we do? You can do the regular log or the natural log, it doesn't matter. And when we do that, we know the exponent comes down in front. So if I'm trying to solve for t and t is multiplied with all this, you can just divide by it all at once. So t equals, when you plug this in, log 2.7 divided by, you need a parenthesis around the entire denominator, 4 log 1.005. And we get 49.7866 years. So this is going to take almost 50 years to grow to the amount we want. Any questions on this? The last thing I want to mention today, flip back to the front. That final box there is the change of base formula. So we have 2 log buttons on our calculator, log base 10 and the natural log, which is log base e. This is telling us if I want to evaluate any other log, I can do so. If I have log base a of m, you can change it to whatever base you want. You do log of the argument over log of the current base. So for example, if I said log base 5 of 7, So you can't plug log base 5 7 in your calculator. I'm going to tell you when I put these on the test, if you do not show the work, you get 0 points. Okay, because there are certain calculators that do allow you to change the base, so to keep the playing field level, you have to write down what you're plugging in your calculator or you don't get credit for it. We can change it to whichever log we want, so if I wanted log base 10, you just do log of the argument, so log of the big number over log of the base. So that's what I'm typing in. This is the work you have to write down on the test to get credit. And that gives me 1.2091. So now we can do any log we wanted in our calculator. You can also, if you typed in the natural log 7 over the natural log of 5, you get the exact same thing. So it doesn't matter which one you pick. So B, how would I write that one? Okay. So log 0.1 divided by log 2. We get 3.3219. That is the only formula from today that you have to know. Okay, anything else, if I were talking about interest or pH or anything like that, I would give you the formula. Any questions for me? So there's a Math Excel assignment posted. A lot of them are like these, the change of base problems, so they're going to go pretty quick. But you've got the next 18 minutes to work on that.